Conformations in cycloalkanes. In this module you will learn about the conformations in cycloalkanes with a focus on the conformers of cyclohexane. You must have learned that carbon-carbon single bonds in alkanes can rotate freely about their axes. The different spatial arrangement of atoms and groups of atoms of an alkane arising due to this free rotation of a carbon-carbon single bond are called the conformers of the alkane. The various conformers of an alkane are identical and can be converted from one to other. However, the free rotation of the carbon-carbon single bond is restricted to some extent as a result of the steric hindrance arising due to the repulsive interactions between the adjacent bonds. Consequently, different conformers of an alkane differ slightly in energy. However, this energy difference between the conformers is very small in case of open-chain alkanes. Therefore, the different conformers of an open-chain alkane cannot be isolated. On the contrary, in case of cycloalkanes, the energy difference between the different conformers is appreciable enough to isolate them. The conformer having the lowest energy possesses the highest stability. For example, for cyclopropane, the planar conformer possesses the minimum energy and is the most stable, whereas for cyclobutane, a non-planar butterfly-shaped conformer is the most stable. Likewise, for cyclopentane, a non-planar conformer with an open envelope shape is the most stable. In the chair form, the 12 carbon-hydrogen bonds of cyclohexane are different. 6 out of the 12 carbon-hydrogen bonds point up or down with respect to the plane of the ring. Such bonds are parallel to the symmetrical axis of the molecule and are called the axial bonds. The remaining 6 carbon-hydrogen bonds, on the contrary, point along the plane of the ring and are called equatorial bonds. The axial and equatorial carbon-hydrogen bonds can be converted from one type to the other, giving rise to two possible chair conformers of the cyclohexane. These two chair conformers of cyclohexane remain in equilibrium with each other and are converted from one form to the other by a process called ring flipping. During ring flipping, all the axial bonds of a chair form get converted to the equatorial bonds and all the equatorial bonds get converted to axial bonds. The transformation of one chair form to the other by ring flipping takes place through an intermediate form called the boat conformer of the cyclohexane. The boat conformer of the cyclohexane is highly unstable because two pairs of carbon atoms in the boat conformer form the eclipsed bonds. If the two carbon atoms are bonded in a way so that the hydrogen atoms bonded to them lie as close as possible, the carbon atoms are said to form eclipsed bond. The eclipsed bonds result in the higher energy and therefore lower stability of the conformer. In this module you have learned the different spatial arrangements of atoms and groups of atoms of an alkane arising due to the free rotation of a carbon-carbon single bond are called the conformers of the alkane. The free rotation of carbon-carbon single bond is restricted to some extent due to the steric hindrance, as a result of which different conformers of an alkane differ in energy. Different conformers of an open-chain alkane are not isolable, as the energy difference between different conformers is very small. But in case of cycloalkanes, the energy difference between different conformers is appreciable enough to make them isolable. For cyclopropane, the planar conformer is most stable. For cyclobutane, a non-planar conformer having butterfly shape is most stable, and for cyclopentane, A non-planar conformer with an open envelope shape is more stable. The most stable conformer of cyclohexane is the chair form. The interchange of axial and equatorial bonds of chair conformer gives rise to two possible chain conformers which remain in equilibrium with each other. The transformation of one chair form to the other takes place by ring flipping through a relatively unstable intermediate called the boat conformer of the cyclohexane.